At the heart of our galaxy, there is a sleeping giant that does not breathe, does not beat, and does not shine. It bends space itself. It is called Sagittarius A*, the monster at the center of the Milky Way. Tonight, as you settle into the dark and let your eyes grow heavy, we will drift there together, not with rockets, but with quiet attention toward a place where gravity is so strong that even light loses its way. Picture a river of stars curving across the sky. Every one of those stars, including our sun, moves in a graceful dance around an invisible partner far away in the constellation Sagittarius. That hidden partner is not a star or a cluster. It is a black hole weighing about 4 million times as much as the Sunday. If the word black hole makes you picture a cosmic vacuum cleaner, take a breath and let that image soften. A black hole does not roam the galaxy, sucking up everything in its path. It sits, it waits. It follows the rules of gravity that guide planets and moons. At our distance, about 26,000 light-years, we are safe and steady. The Sun will continue its slow orbit around the galactic center for billions of years. So why do we call it a monster? Because of what it can do to the things that wander too close. A star that strays near the edge of the abyss can be stretched thin, heated, bright, and torn to glowing shreds. Those shreds swirl into a hot whirlpool called an accretion flow. Friction there makes gas shine in X-rays and radio waves. We cannot see the black hole itself, but we can see the light made by matter as it gives up its last energy and disappears. That light told astronomers where to look. For decades, patient observers watched a cluster of fast stars near the galactic center. They traced tight ovals and sharp turns, some whipping around the same point in space in just a handful of years. The orbits were so precise that only one explanation made sense. An unseen mass so concentrated, so compact, that nothing else could fit the data. That is how we knew the size of the monster's appetite and how we learned its true nature. In 2022, a global team of radio telescopes stitched Earth into one giant lens and imaged this darkness by photographing its halo. The picture showed a hazy ring of light with a dark center, like a glowing donut. That ring is not the black hole, but the last light circling the drain, bent and lensed by gravity. Do not worry about the word horizon. At human size, it sounds close, like a cliff edge you could walk to. Here, the event horizon is the boundary where escape is impossible. Cross it, and every path forward leads deeper in. Stay outside, and you can still orbit, still glow, still send your story to us across the darkness. The horizon is not a wall. It is a point of no return, shaped by space itself. Imagine flying inward now, gently, as if the galaxy were breathing you toward its heart. The star fields grow crowded, dust clouds thicken and glow in warm reds. Space is not empty here. It is a city of invisible winds. Every so often, the black hole burps short flares of light from sudden infalls of gas, like embers tossed into a breeze. Then the calm returns, as if a giant rolled over in its sleep. There is comfort in this scale. The monster has been there since before our planet cooled, and it will remain long after our oceans fade. It is a reminder that the universe is vast, slow, and orderly. Gravity is patient. Orbits are patient. The center holds. When thoughts feel crowded, picture those stars near the core swinging through long loops, knowing exactly where to be and when to turn. If you are hearing about black holes for the first time, you may wonder what is inside. No one can say for sure. The math points to a place where density climbs without limit, where the map of space and time folds in on itself. But for us, outside the horizon, the details do not matter. What matters is what we can observe. Hole on stars, the light from gas, the shadow cast upon the shining ring. Science lives there, on the edge, measuring what can be measured and letting mystery be a kind of quiet. As you listen, let your breathing match the slow rhythm of the galaxy's spin. Imagine the Milky Way as a calm, turning disk. The music is gravity. Sagittarius A times is the center pin. We are a tiny groove far from the label, circling every 200 million years, one more lap, then another, and the night sky changes like seasons on a grand scale. Soon we will explore how astronomers weigh the black hole, how they follow the star named S2 as it slings close and speeds away, and how time itself runs a shade slower near that gravity. We will meet clouds of gas that dare to approach, and the quiet jets that sometimes whisper outward. But for now, rest in the picture: a dark center, a warm ring, a crowd of stars, and a great stillness that is not empty, but full of order. You are safe here, far away. Looking in, the monster at the center of our galaxy does not chase. It simply curves space, and by that curve the Milky Way keeps its shape, and by that shape we find our place. Let the thought of it be a cradle as you drift. When you are ready, we will go deeper. We will step closer, not to fall in, but to understand. The center is calling, and the path is gentle. We promise to go deeper, and we will, but gently. We are not racing toward danger. We are strolling through evidence, the quiet trail of clues that showed astronomers there is a black hole at the center of the Milky Way. Imagine pulling on a soft thread until a whole picture unfolds. That thread begins with light, and with the ways we learn to see through the galaxy's dusty heart. If you could fly straight toward the center with ordinary eyes, you would hit a wall of darkness long before you arrived. Clouds of fine dust block visible light like smoke in a room. But darkness at one color is not darkness at all colors. Infrared light slips through the dust, and radio waves stroll through. So we built instruments that see in those colors, tuned to the faint glow of stars and gas hidden from view. Think of them as fog lights for the galaxy. Even with the right wavelengths, the view is shaky. Earth's atmosphere shimmers and blurs the tiny details we need. To fix this, engineers taught telescopes to unwiggle the sky. They shine a harmless laser into the upper air to make a fake reference star, then bend a thin mirror hundreds of times each second to cancel the blur. The method is called adaptive optics, but you don't need the name. Just imagine cleaning a smudged window in real time until the stars snap into focus. Now the scene comes alive. Near the center, a handful of stars trace lightning-fast loops, tight ovals that fit within a space smaller than the orbit of Pluto. Each one feels the pull of a single invisible mass. One star in particular, known as S2, became the clock by which teams kept time. Year after year, they measured its path as it swung wide and then dove close, carving a full loop in about the length of a teenager's life. When it skimmed by the center, it moved so fast that its color shifted, a sign of gravity's grip and of time running a touch slower near the black hole. From those tracks, the mass revealed itself. The curves act like scales. Only a compact object with millions of suns packed into a space smaller than our solar system could make those orbits work. A cluster of dark things, dead stars, faint dwarfs, would quickly scatter, collapse, or shine in ways we would notice. The simplest answer fit the data best: a supermassive black hole. 2 decades of patient watching, 2 teams on different continents, and a single conclusion. Then came the photograph that was not a photograph in the usual sense. A network of radio dishes around the world, linked together to act like a planet-sized eye. By catching timing patterns in radio waves, and by using Earth's rotation as a slow sweep of the lens, they outlined a soft ring around a dark center. That ring is light from hot gas skimming the brink, bent by gravity into a halo. The dark middle is not a hole in space, but a shadow, the region where light falls inward and does not return. For the first time, we saw the outline of our galaxy's central shadow. What is it like in the neighborhood around that shadow? It is busier than empty space, and calmer than a storm. Threads of magnetic field run like unseen rails. Puffs of gas drift in from the inner galaxy. Sometimes a small cloud wanders too close, stretches, heats, and flashes. We call these moments flares. But do not picture a roaring blowtorch. They are brief, like cosmic sparks. The black hole is not feeding on a steady river. It is nibbling, and between bites, it rests. All of this, and we are still far away. We sit in the suburbs of the Milky Way, about 26,000 light-years from downtown. From here, the black hole's gravity is a gentle background note in the music of the galaxy. The sun and its planets move on a smooth track that takes hundreds of millions of years to complete one circle around the center. The monster's influence is grand, not personal. This distance is a gift. It lets us watch without worry, to learn without urgency. Our telescopes become time machines in a slow universe. By comparing images taken years apart, we watch stars trace their loops like careful dancers hitting each mark. We see the slight drift in those loops, caused by curved space itself, the way a spinning coin traces a spiral on a table. We measure how time behaves where gravity is strong, and in doing that, we test our deepest ideas about the world. If you like a simple picture to carry to sleep, hold this one. The center of our galaxy is a dark kernel wrapped in a warm ring, surrounded by a swarm of quick stars. We know it is there because stars move as if tied to an anchor we cannot see, because light behaves as if space itself is bent, and because a planet-sized camera stitched their signals into a tiny crescent of proof. No single clue is enough. Together, they sing the same song. Let that be comforting. The universe is not guessing. It leaves tracks. We follow them. With steady instruments and calm minds, we turned a rumor into a portrait. In the next step of our journey, we will ask what happens when a star dares to cross too close, how tides of gravity can pull matter into strands, and why the word spaghettification is both funny and accurate. For now, let the certainty settle in. The monster is real, it is quiet, and it holds our galaxy together. Breathe slowly, and imagine the stars near the core, drawing their neat ovals again. Each one returns to where it began. Each one confirms the center without ever touching it. In that rhythm there is peace, and in that peace, sleep. We have reached the shoreline of the black hole's influence, where gravity does more than pull its sculpts. To feel what happens when something wanders too close, begin with tides. On Earth, the moon tugs a little harder on the ocean facing it than on the far side. That tiny difference lifts and lowers the seas. Near a black hole, that difference is not tiny. It becomes a powerful stretch that can turn solid things into threads. Picture a star taking a risky shortcut past the center. It is not aiming to crash, only to pass close. The side of the star facing the black hole feels a stronger tug than the side turned away. The whole star is squeezed and pulled like dough being rolled thin. If it crosses an unseen limit, the place where the black hole's tide beats the star's self-gravity, the star comes apart. Matter streams away in a bright ribbon, one end leading like a kite tail in a strong wind. This unspooling is often called spaghettification, a playful word for a serious process. Think of it as gravity's weaving. The ribbon is not smooth. It twists into a lumpy strand that wraps around the black hole. As sections of the strand rub together, they heat and glow. The broken star becomes a necklace of hot beads, and each bead is a flare of light. The galaxy notices, we notice. The drama is quieter than movies suggest. Space carries light, not sound. From far away we would see a gentle rise in brightness, a fast peak, then a long, steady fade, like a dimmer switch sliding up and then easing down. The black hole feeds, then rests, and the neighborhood returns to calm. Not every visitor meets such an end. Some stars skim close, bow to gravity, and sling back out, scraped but whole. Their paths reveal the landscape we cannot see. Close to the center, space curves like a funnel. The safest routes are wide loops. The dangerous ones cut through narrow canyons, where tiny changes in aim lead to very different futures. A small nudge from a passing star can steer a traveler into a gentler arc or into the waiting tide. What happens to matter that does not escape? It doesn't fall straight in. It spirals. Picture leaves caught in a whirlpool. Torn gas wraps around, then flattens into a hot, thin flow called an accretion flow. Friction inside that flow squeezes out energy. The gas heats until it shines across many kinds of light, from radio to X-rays. Magnetic fields thread the flow like wires, guiding and stirring it. Near the inner edge, a bright hotspot can appear, just a patch where the gas is a little denser or moving a little faster, circling the shadow like a glowing ember, making laps, a tiny lighthouse on a very fast track. As it orbits, its light can flicker, giving us clues to the speed and size of the innermost flow. Clouds of gas meet a similar fate. They drift inward like fog banks, shear into sheets, then into filaments. Those threads collide, lose energy, and sink closer to the center. Dust melts. Molecules break. At each step, the colors of the light change. By watching those colors, astronomers learn how the gas cools, how fast it falls, and how near it dares to go. It is like watching a far-off storm and discovering its shape from the lightning alone. Sometimes the black hole does something surprising. It gives part of what it takes. Magnetic fields can twist near the center and fling out particles in narrow sprays called jets. In other galaxies with larger meals, those jets punch across thousands of light years. At our center, any jets are small and quiet, more like breath than fire. But the rule is the same. Gravity gathers matter inward. Spin and magnetism can send a fraction outward along the poles, carrying energy back into space like a whispering fountain. Through all of this, the event horizon keeps its steady meaning. There is no wall, no flash when matter goes in. From our side, the last steps look ordinary. The light simply goes missing. Time near the edge runs a little slower than it does for us, so the dance of the hot gas appears to lag, but it does not stop. The story continues inside, beyond our reach. If all of this feels like a lot, soften it into one picture you can keep as you drift toward sleep. See a dark center wrapped in a warm, faint ring. Around it, imagine soft streams of gas curving inward, like scarf tails in a breeze. Picture the occasional bead of brightness circling, brightening as it comes toward you, dimming as it moves away. Then the bead fades, the scarf unwinds, and the ring glows on in a steady hush. There is deep reassurance in how nature handles extremes. The same gravity that keeps your feet on the floor is the gravity that tears a star into filaments and lights a halo around a hidden core. One law, one set of rules, working from the scale of a mug on a table to the scale of a galaxy turning in the dark. You do not need equations to feel that unity. You can rest in it. When you are ready, we will widen our view and see how this central engine shapes the city of stars around it. We will trace the bar and the spiral arms, listen to the slow traffic of gas clouds, and learn how a quiet black hole can still govern the rhythm of a galaxy. For now, breathe, and let the image of that soft ring float behind your eyes like a safe, distant lantern. We step back from the shadow and let the whole city of the Milky Way come into view. From far above, the galaxy looks like a calm, slow whirlpool. Two wide spiral arms, a faint third, and an elongated bar across the middle like a glowing bridge. That bar is not decoration. It is a quiet machine, a conveyor of stars and gas, and at its inner end sits the same dark center we have been visiting. The bar steers traffic. Over millions of years, it nudges cold clouds inward, the way a gentle current guides leaves toward a drain. Follow those clouds as they slide along the bar. They are not smooth, they are clumpy, laced with dust, threaded by magnetic fields. As the clouds sweep around the inner bar, they meet lanes where gravity squeezes them like soft brakes. Shocks ripple through the gas. The clouds slow, collide, and lose a bit of their spin. Piece by piece, angular momentum, spinning energy leaks away. That is how material migrates across the inner galaxy without a hand ever touching it. Most of this inflow does not fall into the black hole. Instead, it collects in a thick ring, a few hundred light years from the center, a zone astronomers call the central molecular zone. Think of it as the galaxy's bustling downtown, dense, dusty, and busy with beginnings. Here, cloud meets cloud, pressure rises, and new stars spark to life. Sometimes they form in clusters so rich that hundreds of young suns glow together, still wrapped in their natal fog. The ring brightens in infrared like warm embers, hidden to ordinary eyes but obvious to cameras tuned for heat. In this neighborhood, orbits are messy. Gravity from the bar, the bulge of old stars, and the deep well of the central mass all pull at once. Paths twist, gas shears into filaments, then knots. The chaos is productive. Friction and crowding help clouds collapse. When massive young stars are born, they send out winds and light that sculpt pillars and bubbles in the dark. After a few million years, some of those stars end in supernovae, stirring the zone again, seeding it with heavier elements, the carbon, oxygen, and iron that future planets will need. The black hole sits just inside this ring like a patient hub. On most days, it is simply part of the gravity field, setting the curvature for the innermost orbits and offering an anchor around which the world can organize. On some days, when a trickle of gas slips closer, it answers with a brief flare. Those flares are sparks in a furnace, not wildfires. In other galaxies, where the central hole feeds more steadily, long jets can punch out and redraw the shape of the surrounding gas. Our galaxy's center is quieter. If the black hole breathes out at all, it does so in soft, local puffs. And yet the Milky Way remembers times when the center spoke loudly, high above and below the disk. Astronomers have mapped enormous, faint lobes, soft balloons of energy rising from the core like twin lanterns. They are called bubbles, and they likely carry the signature of a past outburst, either from a feeding episode at the black hole or from a burst of clustered star formation near it. However they formed, they are ancient footprints of power, stretched over tens of thousands of light years, harmless to us, but evidence that the center can, on rare occasions, exhale with force. Closer in, another kind of memory lingers. X-ray and radio light echoes flicker across dense clouds in the central zone, as if a bright flash from the core years or centuries ago is now bouncing off cosmic mirrors. These echoes are not dangerous. They are simply time-delayed, like thunder arriving after lightning. They let astronomers reconstruct a diary of the center's small tempests, short notes in an otherwise quiet ledger. All of this, the inward drift along the bar, the ring of starbirth, the rare outflow adds up to a living ecosystem. The galaxy does not sit still. It circulates. Gas moves inward. Some of it turns into stars. A trace falls to the black hole, and light and winds push back on the flow. Nothing is wasted. Even the push from young stars and occasional breaths from the core helps keep the downtown from collapsing all at once, spreading out the feast over eons. Now let's widen further, out to the spiral arms. They are not solid structures you could grip. They are more like traffic waves on a highway, regions where stars and gas crowd slightly, slow a little, and then move on. As gas enters those crowded regions, it compresses and forms stars, which light up the arm and mark it for a while. When the stars drift onward, the bright pattern appears to rotate, even though the individual stars are steadily passing through. Our sun orbits in a quiet spur between larger arms, far from the center, where the pace is peaceful. The black hole does not run the arms. Its gravity rules the inner few light years. The bar and the mass of the inner galaxy set the flows out to hundreds of light years. Spiral patterns and the larger dark matter halo guide the disk at the grand scale. Still, the center matters. It provides the deepest anchor point, the calm eye that lets the rest find balance. Remove that anchor, and the very heart of the Milky Way would be different. There is a soothing honesty in how these pieces fit. The bar does not push hard. It simply tilts the odds, so gas drifts inward. The ring does not explode. It quietly builds stars. The black hole does not devour the galaxy. It nibbles, rests, and sometimes whispers outward. Over millions of years, those gentle actions shape the face of the sky we know. The band of the Milky Way that arches over summer nights is the visible edge of that patient circulation. Hold a single picture as you breathe. A bright bar guiding slow rivers of dust, a warm inner ring flickering with newborn stars, a small dark hub at the center, calm and steady. and far out where we live, a thin lane of starlight, turning with the rest. Imagine the galaxy as a great clock that never ticks loud. Its hands are arms, its gears are clouds of gas. Its center pin is the black hole, set deep and sure. In the next part of our journey, we will slow time itself and stand in thought beside a fast star near the core to feel how clocks run differently in strong gravity, why colors shift, and how light curves. But for now, let the larger picture cradle you. The city is organized, the traffic flows, the night is long and kind. We promise to slow time not in your room, but in your imagination, by standing near great gravity and watching minutes behave. Around Sagittarius A asterisk, clocks do not fully agree. A second near the center is not quite the same as a second far from it. That is not poetry. It is the plain way the universe works when space is curved. Picture two friends with perfect watches. One stays with you in the quiet suburbs of the Milky Way. The other takes a safe loop that dips toward the black hole and returns. When they meet again, both watches are honest, yet they disagree by a tiny sliver. The traveler's watch runs a shade slow because time was stretched by gravity and by speed. This gentle mismatch is called time dilation. We do not have to guess. Astronomers turned a fast star named S2 into a moving clock. As it swooped close to the black hole, its light shifted slightly toward the red, and the cadence of its signals changed just enough to match Einstein's prediction. Think of a singer whose note lowers as she steps into a heavy wind. The voice is the same, but the tone leans. In 2018, during S2's closest approach, instruments measured that lean with calm precision. The result confirmed that time and light behave differently near great gravity. Light itself follows curved paths. In flat space, a beam travels straight. Near heavy mass, the route bends as if space were a soft sheet pressed into a bowl. When light skims the center, it curves. An observer lined up just right might see a background star smeared into a pale arc or even split into multiple images. This is lensing. Around a black hole, the bending can be so strong that some light nearly circles before escaping, piling into a thin, bright ring. That ring is part of what a planet-sized radio telescope array helped outline, a bright ring around a dark shadow. What would you notice if you could drift nearby, well outside danger, and look around? You would not see a wall or a mouth. You would see stars moving swiftly, their colors breathing faintly with motion. You would see the inner glow of hot gas brighter on the side, racing toward you, and dimmer on the side, sliding away. That simple brightening is called beaming. Motion tilts light in our direction. If you watched patiently, you might catch a hot spot, a denser knot in the flow making quick laps near the brink, its flicker marking the inner speed limit. There is a last safe path for circular motion. Some orbits are steady and some are not. Close to a black hole, there is an inner edge where stable circular tracks end. Inside that, everything spirals inward. The exact distance depends on how fast the black hole spins, but you do not need the number. It is enough to know there is a line between graceful circling and inevitable falling, and that line sets the rhythm of the inner glow. Even signals feel gravity. A pulse of light sent upward from near the center loses a little energy climbing out. Its color slides toward the red. A pulse sent downward gains energy. Its color moves toward the blue. Radios feel this, and clocks do too. We can time how signals creep when they pass a massive body, as if the road were slightly longer than the ruler says because space itself has stretched. These tiny delays are not errors, they are features, like ripples on a pond that tell you the shape of the pond's bottom. If all of this still feels distant, bring it home with a familiar tool, the navigation in your phone. Satellites high above Earth tick a little faster than clocks on the ground because gravity is weaker up there. Their motion slows them a little at the same time. Engineers correct both effects, so your map snaps to your street. The same rules that keep your route steady also describe the light and time near the Milky Way's center. One framework, many gentle uses. Let the numbers blur and keep the feeling. Gravity does not only pull on things, it pulls on time and on the paths that light prefers. Near Sagittarius A*, seconds lengthen by a breath, colors lean by a hair, and straight lines turn into arcs. Nothing here is abrupt, no gears grind. The differences add up like soft background music, present, measurable, and quietly beautiful. Stand, in thought, beside S2 at the point where it swings closest. The star whips around the corner like a dancer leaning into a turn. Its clock runs just a touch slow. Its color drifts a breath toward red. Look inward, and you see the halo, not a hard ring, but a fuzzy wreath stirred by fresh gas. Look outward, and you see the broader city of the galaxy, bar, ring, and arms turning with patient grace. Between these views, you understand. Time here is not broken. It is simply part of the landscape. Breathe with that thought. In the vast night, no one asks you to solve equations. Carry the picture instead. Heavy things bend space. Bent space tells matter and light how to move. Their motion tells us where the heavy things are. We check, we measure, and the universe answers softly that the rules hold. In the next part, we will meet the people behind these insights, the watchers on mountaintops and in desert arrays, the builders who turned Earth into one giant eye, the patient teams who return night after night to mark a star's place to the width of a hair. Their work is quiet and steady and full of wonder. For now, let the idea of slow seconds near the core be a warm blanket. Time, like the galaxy, is gentle at large scales, and it will carry you toward rest. We promised to meet the people behind the picture, so let's climb the mountains where they work. The air is thin, the nights are steady. On Mauna Kea, in Hawaii, two giant mirrors called Keck watch the galactic center with laser-guide stars that steady the blur. In Chile's Atacama Desert, the Very Large Telescope does the same from Paranal, its 4 domes turning like quiet whales under the Milky Way. These are patient places. Every clear night, teams return to the same crowded patch of sky and mark the positions of quick stars, one by one. Some of those watchers are astronomers, some are engineers, many are both. They tighten bolts, cool instruments, and write code. They carry notebooks filled with tiny plots and quiet questions. The work is not dramatic. It is a long conversation with the sky, full of pauses. You gather a little data, you check, you fix, you try again. Over months and years, the points make trails. The trails curve. From the curves, the mass at the center reveals itself. This is how we learned that a single, compact giant must sit there, unseen but undeniable. In 2020, the slow, careful work was honored. A Nobel Prize recognized the discovery that a supermassive black hole sits at the heart of the Milky Way, and the theory that explains why gravity there behaves as it does. Awards are not the reason anyone holds a telescope through a frozen night, but they mark the turning of rumor into certainty. They tell the world that patience matters, that small improvements add up. Now shift to a different kind of machine, an eye as wide as Earth. The Event Horizon Telescope is not one dish, but many, scattered across high deserts and icy plateaus. Each one listens to radio waves from the same target at the same time. Atomic clocks keep them in step. Later, mountains of recorded signals are flown to special computers and combined. This method, very long baseline interferometry, stitches the pieces into one sharp view, the way separate microphones can reconstruct the directions of faint whispers. The people who make this happen do more than point antennas. They tune receivers to stay quiet in the cold. They climb ladders to brush snow from domes. They monitor the wind. They argue and agree about how to clean the data, building several independent pipelines so that no single choice can mislead the whole. They repeat the work in teams that do not see each other's answers until the end. Only after many checks do they dare say, yes, this is the ring. Closer to home, other instruments keep watch in different colors of light. NASA's Chandra X-ray Observatory and ESA's XMM Newton look for hot gas and quick flares. ALMA, a field of radio dishes in the Atacama, measures the whisper of cool dust and the slow drift of molecules. Infrared cameras on Keck and the VLT follow the tight stars year after year. No single tool tells the whole story. Together, they make a layered portrait, hot and cold, fast and slow, near and far. If you imagine science as a single voice making a bold claim, let that picture soften. Real science sounds like a choir. Someone suggests, someone checks, someone else improves a detail no one noticed before. The loudest notes are not shouted. They are repeated by many instruments until the harmony is clear. When the star S2 swung closest in 2018 and its light shifted, just as theory predicted, it was not one person who smiled. It was hundreds, connected by late-night emails and dawn coffees, each holding one small piece of a shared result. The human side matters. A telescope is steel and glass, but it is also a promise that people will keep showing up. On a winter night, a technician warms frozen fingers before reseating a cable. In thin mountain air, a graduate student steadies a laser that pretends to be a star. In a hangar full of hard drives, an engineer labels boxes of signals to ship to a faraway lab. In classrooms, mentors teach the next set of steady hands. The galaxy is vast, yet knowledge grows one careful adjustment at a time. There is also respect for the lands that host these instruments. Mountains like Mauna Kea are sacred to many. Observatories work with local communities, listen, adapt, and try to tread lightly. The sky belongs to everyone, and the best science is done with humility. When you picture the domes, picture people inside them remembering where they stand. What do all these efforts buy us? A clearer sense of our address in the universe, and a gentle correction to our sense of scale. We learn that the Milky Way is organized, that its center holds, that extreme gravity can be studied with simple patience. We learn that collaboration across continents can act like a single mind. And we learn that even in a world full of noise, there is room for long projects that ask us to be calm. Hold a small scene as you rest. A row of domes opens at dusk. The air is still. Screens glow with soft graphs. A star named S2 creeps a fraction across a pixel. In another hemisphere, a radio dish turns and locks. Atomic clocks hum, hard drives spin. Above it all, the center of the galaxy waits, unchanged by our attention, yet generous with clues. The work is quiet, but its meaning is large. In our next step, we will return to the black hole itself and consider its spin, its appetite, and its past moods written across the sky. For tonight, let the image of patient hands and patient machines be enough. People, scattered under different stars, looking at the same dark heart, breathing in time with the Earth, and adding one more careful line to the story. We return to the dark heart and ask 3 gentle questions. How fast does it turn? How much does it eat? And what stories does it leave behind? These sound like human questions, and that is fine. A black hole is not a person, but the answers, in plain words, help the picture soften and settle as you rest. First, the turn. Spin is simply rotation, the swirl left over from the gas and stars that fed the black hole, and from the mergers that shaped it. If you slowly stir honey, the whole jar begins to twist. Near a black hole, something similar happens, only the effect is woven into space itself. The spin drags the fabric of space-time and tugs on the paths that light and matter prefer. Imagine a gentle twist in the floor beneath every dancer. Steps that would be straight become soft arcs. Spin sets the inner rhythm. There is a last safe racetrack where hot gas can circle without falling in. If the black hole turns with the orbiting flow, that racetrack sits closer to the center. If it turns against the flow, the edge lies farther out. You do not need the distances. It is enough to know that spin slides that boundary and changes how bright and how quick the inner glow can be. Around Sagittarius A*, hints in the timing of flickers and in the way light is polarized suggest that it rotates, probably at a modest pace rather than an extreme one. We cannot yet pin down the exact value, but the picture that fits best is a steady, not frantic, spin. Spin does more than mark a track. It can also guide outflows. When magnetic fields thread a spinning black hole and the hot gas around it, they act like springs. Some of the system's energy can be channeled outward along the poles as a breeze or a small jet. In our galaxy, if such outflows appear, they are gentle and local, more a breath than a blowtorch, but they still matter. A small push can keep some incoming gas from reaching the center, helping the black hole stay quiet most of the time. Now, the appetite. Our black hole is famously underfed. In a universe where some central giants blaze as quasars bright enough to outshine their whole galaxies, Sagittarius A times is a campfire on a quiet hill. It sips rather than gulps. Streams of gas do approach the center, but most of that material is too warm and too thin to settle. Much of it loops once and flows back outward in a wind. Some slips into orbit and slowly spirals inward, and only a tiny fraction makes it all the way across the edge of no return. The result is a dim, steady glow instead of a roaring beacon. Why so faint? Because thin gas is a poor radiator. In dense places like the surface of a star, atoms bump often and share their heat as light. In the sparse inner whirl near Sagittarius A asterisk, particles pass like distant cars on a highway at night. They keep most of their energy and carry it along rather than shining it away. Astronomers call this a radiatively inefficient flow. You do not need the term to feel the idea. When the pantry is bare and the soup is thin, the stove glows softly. Flares are the exceptions, and they help us learn. Every so often the black hole brightens for minutes to hours. The likely cause is turbulence and magnetic mischief inside the inner flow. Magnetic field lines can twist until they snap and reconnect, dumping energy into small regions much like solar flares on our sun, but in harsher gravity. A denser knot of gas can also swing by on the inner track, shining brighter as it races toward us and dimmer as it rounds the far side. From those brief flickers we learn about speed and size near the brink, because the faster the flicker, the tighter the track. What about moods long ago? The Milky Way remembers. High above and below the disk rise vast, faint lobes, ancient bubbles of energy that likely trace a past outflow from the center. Closer in, dense clouds carry light echoes in X-rays and radio, delayed reflections of brighter days that let astronomers reconstruct a quiet diary of recent flares. And there was a visitor nicknamed G2, a small, dusty object that swooped near the black hole about a decade ago. Some expected fireworks. The pass was quieter than headlines promised, and that too taught us something. The object may have been a star wrapped in dust, or the gas may have smeared into the flow instead of crashing all at once. Either way, the lesson was patience. The center does not put on shows on command. Where does the food come from in the first place? From the neighborhood itself. The central few light years are crowded with young, massive stars that shed steady winds. Those winds collide and warm the gas, stirring a hot, slow stew. A fraction of that stew drifts inward. Along the way, magnetic fields act like rails, guiding the flow and resisting it at the same time. With sensitive radio cameras, astronomers have mapped strands of those fields. Their orderly patterns suggest the inner gas is not chaos, but a woven, shifting fabric. Add these pieces together, and you see a loop. A rotating black hole can help launch breezes that nudge nearby gas outward. Those breezes make feeding harder, which keeps the hole dim. When a little more gas slips through, the system brightens, then self-calms. It is not a tantrum, it is a thermostat. Over long stretches of time, the center regulates itself, staying faint compared with the roaring hearts of distant active galaxies. Bring the picture together in one calm frame. See a dark core with a soft, glowing wreath. Imagine the wreath threaded by invisible lines, its inner edge set by spin. Picture most of the nearby gas missing the mouth and drifting away as a warm sigh, while now and then a brighter bead lights up, circles fast, and fades. Around all of it, the downtown ring of the galaxy keeps making stars, sending new winds, renewing the supply, and letting the story continue at a sleepy pace. If you like to anchor images to familiar names, remember the watchers that help us see these details. Alma's field of dishes in the Atacama, measuring cool dust and molecules. Infrared eyes on Mauna Kea, and Paranal tracking fast stars. Space telescopes like Chandra and XMM Newton tasting hot gas above our air. And the Earth-sized Event Horizon telescope tracing the shadow's edge. Together they confirm the essentials. Sagittarius A times turns. It sips, it occasionally stirs, and across millions of years, it acts as a steady hub rather than a roaring engine. Let that steadiness be your lullaby. Extremes do not always shout. Sometimes they hum. At the galaxy's center, a simple rule keeps playing. Gravity gathers, spin guides, magnetism threads, and light carries the news. You do not need to solve anything tonight. It is enough to know that the monster at the core is more caretaker than menace in our era. The city of the Milky Way turns around it, unhurried, balanced, and kind. We turn our attention to the stars who live closest to the dark heart, neighbors that move fast, grow up strangely, and sometimes get tossed out of the galaxy. Their lives are short and bright, like sparks near a campfire. By watching them, we learn how gravity writes stories on human scales of years and decades, not only in the language of eons. Right around the center, there is a tight crowd called the star cluster. These stars loop through space like skaters on a tiny rink, each one tracing an oval around the same unseen point. Some complete a lap in just a few years. Their paths are not guesswork. They have been measured, dot by dot, night after clear night. Together, those dots drew the picture of the black hole's mass. But the cluster carries another puzzle. Many of these stars are young, hot, and massive. How did such tender stars grow up near such harsh gravity? There are two gentle answers, and they may both be partly true. One idea says the stars formed right there, inside a dense disk of gas that settled close to the center for a time. In a disk, gas can cool, clump, and turn into stars even under strong gravity, the way raindrops form in a spinning storm. Another idea says the stars were born farther out in a tight cluster, then drifted inward together as friction with surrounding gas and stars robbed them of a little spin. Over time, the clusters scraped into the inner zone and spread out, leaving its members to find their own fast paths. Either way, the lesson is simple. Even near a black hole, nature finds room for new light. The neighborhood is not only young stars. There are older suns, faint dwarfs, and likely many dark leftovers, white dwarfs, neutron stars, and small black holes too dim to see directly. Think of them as pebbles mixed into the sand. Their quiet gravity jostles the orbits of the visible stars. Over long stretches, these nudges make paths wobble and precess, turning perfect ovals into slow, rosette-shaped loops. By measuring those shifts, astronomers hope to weigh the hidden crowd and learn how busy the dark zoo really island. Sometimes the black hole and a passing pair of stars meet in a special way that sends a clear signal across the galaxy. Picture a close duo, two stars bound together wandering near the center. The black hole grabs one star and flings the partner away. The captured star joins the inner family. The ejected one leaves at such speed that it can escape the Milky Way altogether. These are hypervelocity stars, cosmic runners launched by a single close encounter. We have found a handful far out in the halo, moving too fast to be explained by ordinary pushes. Their paths point back, like arrows, to the inner city. The center does not only swallow, it also throws. Planets can be part of this story too. Near the core, steady orbits are hard for small worlds to keep. Tides tug, close passes rattle, and radiation from hot young stars can strip away air. Yet farther out, where the crowd thins, planets should be as common as anywhere. If a hypervelocity star once had planets, those worlds might be left behind or carried along, frozen passengers on a long ride into the quiet outskirts. We do not have clear detections yet, But the same rules that make planets near our sun also work in most corners of the galaxy. Nature repeats. The center also hosts long, thin radio filaments, threads of emission that run like harp strings across the inner region. They trace magnetic fields, the same invisible lines that guide charged particles in the hot gas. In places where the threads cross clouds, the glow brightens, as if a bow had struck a string. No need to memorize names or lengths. Keep the picture. The inner galaxy is not a blank. It is stitched with lines of force, and those lines help shape how gas moves and how stars are born. In the infrared, astronomers see a warm ring of star-forming clouds circling a few hundred light-years out, busy with new clusters. Every so often, winds from those clusters push inward and brush the inner light year. The result is a change of weather at the core, slightly more fuel, slightly brighter flares, then calm again. Think of city neighborhoods feeding a quiet downtown with a slow flow of commuters. The rhythm is not dramatic, but it keeps the heart supplied. Closer still, within a few light days of the edge, the hot gas can flicker in polarized light that prefers certain directions. That preference tells us how magnetic fields thread the flow, twist near the horizon, and sometimes reconnect in short, energetic bursts. If a bright knot circles quickly, its polarization angle can swing in step, like the hand of a small clock. These tiny swings become clues. They hint at how close the inner track lies, how strong the fields are, and whether the gas orbits with or against the black hole's spin. We read them the way a sailor reads the set of the wind on a distant flag. Even the space between stars plays a part. Dust and gas along our line of sight scatter and absorb some colors and let others pass more easily. That is why radio and infrared light are our main messengers from the core. They stroll through the haze where visible light is stopped, carrying news from the city center to our quiet suburb. A radio wave that left the core when ancient humans were learning to shape tools arrives at our dishes today, unchanged by the miles. We do not rush it. We listen. All these pieces, young stars on fast tracks, old remnants hiding in the crowd, magnetic strings, gentle inflow from the inner ring, faint flares that whisper of spin add up to a living portrait. The center is not a simple drain. It is a neighborhood with traffic rules, streetlights, and seasons. It is quieter than the blazing hearts of active galaxies, but rich enough to keep teaching us how gravity, gas, and starlight choreograph their dance. Hold a single calm image to take into sleep. Imagine a cluster of bright stars looping like fireflies around a dark well, their paths steady and sure. Picture, now and then, a duo straying too close, one star staying, one star flying off into the wide night. See long, pale threads stretched across the scene, marking the direction of invisible fields. Feel the slow breath of the inner ring feeding the center with a thin, warm wind. And at the very core, see the soft, fuzzy wreath of light circling the quiet shadow that anchors it all. In the next part of our journey, we will widen the time frame and visit the future, how the center may change as the Milky Way ages, what happens when our galaxy and Andromeda meet, and how two giants might someday spiral together. For now, let the calm of the present center settle over you. The city holds. The stars know their turns. The night is long and kind. We promise to visit the future. So let us drift forward in time and watch the Milky Way change with the same patience we used to read its past. The center will not stay exactly as it island gravity keeps accounts. Gas keeps moving. Stars are born, live briefly, and give back what they borrowed. The black hole answers in calm pulses, bright for a moment, then quiet again. Begin with the downtown ring of gas and dust. Today, it is a busy workshop, turning clumps into clusters and carving bubbles with winds from newborn stars. Over long stretches, that workshop will slow and restart in cycles. Fresh gas will trickle down the bar, fill the ring, spark new births, and then thin out. Each wave sends a little material toward the heart. Most swirls away on warm breezes. A small fraction reaches the inner track, brightens the wreath, and crosses the horizon. There will be quiet fires, A small cloud plunges inward and stretches. A faint flare marks the moment. A dusty object, the sibling of earlier visitors, skims the edge and blends into the flow. The lesson repeats. Not every close pass is fireworks. Sometimes it is a sigh. Sometimes it is a whisper. All of it teaches us how the inner weather works when fuel is thin. In the deep future, the neighbors will change. The young, hot stars near the core will spend their short lives and fade into remnants. New generations will form as long as the ring can supply raw material. But each round will leave heavier elements behind, the grit of past burnings. Planets born in those enriched nurseries will have the ingredients for rock, water, and complex chemistry. Whether such worlds can endure the tides and radiation near the center is a different question, but even there, nature finds paths to balance. The black hole itself will grow, though slowly. It may merge now and then with smaller black holes delivered by dense star clusters that wander inward. Each meeting will be brief and silent to the eye, but loud in gravity, sending ripples through space-time that wash across the galaxy. Someday, instruments designed to hear long waves may listen to the center's private conversations and tell us which partners fell in and when. Farther forward, the biggest change approaches from across the night. Andromeda, our nearest large neighbor, is gliding toward us on a path so long and gentle that it feels almost still. In a few billion years, the two spirals will interlace, stretch, and settle into a single, giant ball of stars. The word collision sounds violent, but the space between stars is vast. Very few will actually hit. What will change is the pattern. Gravity will stir orbits, mix gas, and trigger bursts of star birth before the system calms again. At the heart of that meeting, two giants will seek each other. Sagittarius A times and the black hole in Andromeda's core are like heavy anchors dropped in the same pond. As the galaxies merge, the anchors sink toward the common center. First, they form a wide pair that circles slowly. Passing stars steal a little energy and carry it away, letting the pair tighten. Gas that drifts in can do the same. Over time, the two black holes become a close duet, their orbits shrinking step by steady step. When they finally draw near enough, their dance will sing in gravitational waves strong enough to be heard across the local universe. To us, long before that day, the merger would appear as a calm brightening of the central regions and a change in the shape of the sky. The duet will take eons to resolve, and when it does, the two will become one heavier heart, spinning with a memory of the directions they turned before they met. What happens to the galaxy around this new center? After the first rush of star birth fades, the mixed system will settle. The spiral arms we know may blur into a rounder cloud of stars. Some gas will be used in the burst, some will remain to drift. The central black hole might enjoy a longer meal during the merger, briefly shining more brightly than it does today. Then, as the pantry thins, it will return to its gentler appetite. The city will not stop. It will adopt a slower rhythm. Think of our distant descendants. They will look up at a different band of stars and still find order. Seasons of star birth will come and go. Clusters will age and dissolve. The center will continue to anchor the whole, not as a tyrant, but as a deep well that holds the sky in shape. Even after the sun has changed and the familiar constellations have drifted, the memory of the Milky Way's heart will live on in the paths that light prefers. On still longer horizons, the supply lines will thin. Star-making will slow as gas is locked into long-lived faint suns and into remnants that do not give their material back easily. The galaxy will grow quieter and redder. The central black hole will keep its post, gaining mass in slow increments from stray stars, wandering dwarfs, and rare clouds. If it feeds more during some late encounter, it will glow. If not, it will rest. The rules do not age. Hold a single image to carry into sleep. Two dark hearts far apart begin a journey toward each other. Around each, cities of stars turn with patient grace. As ages pass, the cities merge into one, and the hearts form a pair, a slow waltz in the deep. They whisper through space with waves we will have learned to hear. At last, they touch and become one. The new center breathes, spins, and steadies the sky that surrounds it. No rush, no threat, only the long, kind patience of gravity, keeping time for a universe that never needs to hurry. We have followed the physics and peered ahead into the future. Now let's walk back through how people found the Milky Way's hidden heart, from legends to radio hiss to a picture of a shadow. Long before anyone spoke of black holes, people traced animals and heroes along the bright band we call the Milky Way. In the south of summer lies the constellation Sagittarius, the Archer. Near its teapot shape, a mist seems to rise, the glow of the galaxy's crowded core. No one in the ancient world knew there was a dark engine there, but they felt the region's weight. Stories gathered where the stars did. The scientific path began with sound you cannot hear. In the early 1930 seconds, Karl Jansky built a rotating radio antenna to hunt static that bothered transmissions. He found a steady hiss from the sky, strongest toward Sagittarius. The galaxy, it turned out, broadcasts. That hiss was the first clue that the center is a special place. Decades later, sharper radio ears mapped the central region. In 1974, Bruce Balick and Robert Brown reported a tiny, bright radio point tucked inside the broader glow. Brown later coined the name Sagittarius A*, the star marking its compact, curious nature. No one had seen a black hole yet, but the dots on the map were tightening. Seeing through the dust took a different kind of light. Infrared cameras on large telescopes punched past the murk. In the 1990 seconds and 2000s, teams on Mauna Kea and in Chile tracked stars near the center night after night. Their orbits were not loose loops in a vague fog. They were tight, precise ovals around a single point. The mass required to hold those stars on course could not be spread out. It had to be packed into a space so small that only a black hole fit. A rumor had become a measurement. The Event Horizon Telescope sealed the picture with an image like a poem, a soft ring framing a dark middle. It is not a portrait of the black hole itself, but of the last light skimming its edge, bent by gravity into a halo. The same technique produced an earlier image of a larger black hole in the galaxy M87. Both rings told the same story of heavy things, bending space and space guiding light. Along the way, language needed care. Black hole sounds like a mouth that swallows. The reality is calmer. A black hole is a place where gravity has tightened so much that escape would require more than light can give. From far away, its pull is simply gravity, obeying the same rules that bind the moon to Earth and the Earth to the Sunday. Words can mislead. Patient pictures correct them. Distance is sharpened, too, by watching how the fast stars swing and how their light shifts. Astronomers pin the distance to the center at roughly 26,000 light-years. That number lets us turn angles on the sky into real sizes and speeds, and sets the scale for the whole galaxy. As instruments improved, the center showed more character. X-ray eyes saw quick flares, brief brightenings when magnetic fields snapped, or when a denser knot of gas made a fast lap. Radio eyes traced long, straight filaments, signatures of magnetic fields, threading the region like taut strings. Infrared eyes watched the star S2 dive at top speed and climb away again, its color leaning just enough to confirm that time runs a shade slower near strong gravity. Every color of light added a line to the story. If you want a quiet timeline to carry into sleep, hold this. First came a hiss from Sagittarius, then a compact radio spark, then infrared maps of swift stars, then an Earth-sized eye drawing a ring. Between those steps were thousands of clear nights, countless adjustments, and the steady work of people who trusted that nature would be consistent if we watched carefully enough. You can also find the center with your own eyes, not as a pinpoint, but as a feeling. On a warm night, far from city lights, look south in summer from the northern hemisphere, or overhead in the deep south. The Milky Way arches like a river. Near the spout of the teapot in Sagittarius, the river brightens, orange and gold. You are looking toward the crowded downtown, toward the place our whole disk orbits. The black hole is there, quiet and indifferent to our gaze, yet still shaping the sky we love. Why does this history help with rest? Because it shows how the universe rewards patience. No single observation solved the mystery. Confidence arrived the way sleep does, gradually, after small noises fade and patterns settle. The same calm attention that finds a ring in radio noise can ease a busy mind. We do not force, we notice. We do not clutch at answers, we let them line up. It also reminds us that science is a human craft. The center of the Milky Way is not only a place, it is a project that joined cultures, languages, and instruments across half a planet. It involved caretaking mountains and deserts and treating the night as a shared inheritance. Knowledge grew without hurry, and sharing it made the world feel larger and gentler. Hold one last picture from this chapter, a desert dawn, domes closing after a long vigil. On hard drives and in notebooks travel new dots, new flickers, small additions to a great curve. The center has not changed. We have. We understand a little better, and the understanding sits lightly. In the next part, we will step closer to the edge in imagination and take a calm, first-person tour of what you would see on a safe approach. The changing sky, the flicker of the ring, the way background stars swirl. For now, breathe out and let the story of how we learned be a soft cushion beneath the story of Watted Island. We promised a calm, first-person tour. Close your eyes and imagine leaving our quiet suburb of stars, drifting inward along the Milky Way without engines, without hurry. The sky thickens. Between familiar constellations, black turns to velvet grain as faint suns appear where emptiness used to be. Shapes, begin to loosen. Patterns stretch and tilt because you are trading a local map for a city view. Dust softens the light. Invisible colors, lanes across the inner galaxy, look like smoke. In your mind, switch to infrared and the lanes reopen. The central bulge swells like a warm lantern behind gauze. The bar of the galaxy crosses your view, a dim bridge guiding slow rivers of gas toward the heart. The currents are veined with magnetic threads, rails for charged particles. The gas compresses and glows a shade brighter where the flow bends. You pause near the inner ring of dense clouds, a few hundred light-years from the center. Think of a downtown at dusk. Some clouds are collapsing into clusters, others wear bubble rims carved by winds from young, hot stars. A few supernovae left hot cavities. You do not need the names. Let the feeling land. Craftsmanship everywhere. No rush. Now we tip inward again. Star density rises. The background begins to flow. It is not wind. You feel it is perspective. Nearer, stars slide. Distant ones hardly move, and the whole field seems to swirl around a point you cannot yet see. Every so often a star brightens and fades by a breath. That is lensing, light nudged by gravity along your line of sight. The effect is gentle. Ahead, a soft wreath appears. You are still several light days away, far outside danger. The ring is not a hard circle. It breathes. One side glows a touch brighter and bluer where gas races toward you. The far side gentles and reddens as it slides away. A brighter knot creeps around the rim like an ember making laps, sometimes splitting in two, sometimes merging again. Inside the wreath sits a shadow where light does not return. If you could switch senses, radio would turn the scene into a whispering shimmer. X-rays would add brief sparks when magnetic lines snap. In polarized light, the glow shows a faint swirl, an imprint of fields. You do not need to analyze it. Notice the rhythm, like a sleeping cat's breath. Between you and the wreath streak a few fast stars, the stars and their kin each on a private oval. One dives by with a tiny shift toward red as it skims lowest, its light stretched by gravity. Another draws a petal instead of a perfect loop. That is precession, the slow turn written by curved space and by quiet nudges from hidden neighbors. These details are not homework. The center is precise, yet flexible. Look a hair inside the glow and sense a thinner, tighter ring. the path of light almost trapped, circling nearly once before escaping. In reality, it is many near loops, too fine to separate, felt as a delicate rim. If the black hole spins, the rim shifts a little, like a coin seen at an angle. The overall picture remains simple: a dark heart, a hazy halo, a moving ember. Hold your place and let minutes pass. The ember brightens, fades, and brightens again. Turbulence thickens a patch. Magnetic mischief releases heat. A modest flare rises and eases down over the time it takes to finish a cup of tea. The ring returns to its hush. Beyond it, the bulge is warm fog. Constellations are only rumors here. Check in with your body in this imagined place. You are safe and still. Gravity here is not a tug on your shoulders. It is the shape of the map. If you chose to circle, you could, but this tour is about sight, not speed. Notice how your sense of time softens. Nothing is abrupt. The scene changes like tide, not like thunder. Turn, the wreath slides aside, and the starfield returns. Long, pale threads cross the view like strings laid over velvet. These are radio filaments, places where magnetic lines and fast particles cooperate to glow. Where a string meets a cloud, the line brightens for a moment, then returns to a quiet course. They are landmarks, proof the inner region is stitched, not smooth. Face the ring again for one more look. Relax your gaze. The shadow steadies. Around it, the hot flow blurs into a halo. And beyond that, the crowd of stars thickens into granular fog. Imagine every point has a biography: birth, cloud, path, neighbors, future. Somewhere, a hypervelocity star flung long ago from this hub is crossing the far halo. Somewhere else, a compact cluster is inching inward, star by star. All of it is slow, patient, lawful. Begin to lean away. The wreath shrinks. The background steadies. Dust lanes regain contrast, and constellations start to settle back into the patterns you learned as a child. In your chest, your breathing has found the galaxy's rhythm again, long in, long out. You have stood gently, safely near the heart of the Milky Way, and watched light behave. Carry the picture home: a soft wreath, a calm shadow, a wandering ember, a city of stars around a quiet well. When thoughts are busy, return to this balcony. Let the slow glow be your metronome. The monster at the center does not chase, it anchors. By that anchor, the galaxy keeps its poise, and by that poise, your mind can loosen and rest. Let's answer the quiet questions that linger when you hear about a black hole, then fold them into one calm picture you can keep. Each answer is short and gentle, no math, just tidy threads so your mind can rest. Will it swallow the galaxy? No. Gravity weakens with distance. At our address, about 26,000 light-years away, Sagittarius A tugs on the sun the way any deep, faraway mass would, firm enough to keep our orbit steady, far too gentle to disturb daily life. We are not on a conveyor belt into darkness. We circle safely. Could it suddenly turn on and blaze the sky? Only if it were fed. Bright outbursts in other galaxies happen when their central holes are stuffed with gas. Ours lives lean. Most incoming gas is lost to warm breezes before it reaches the edge. Flares will happen, brief brightenings that last minutes to hours, but the roaring beacon of a quasar is not in our forecast. Do black holes move? Yes. Like any heavy object, they can drift, wobble, and orbit. Sagittarius A sits near the Milky Way's center of mass and jiggles slightly as nearby stars tug. Long ago, it likely grew by merging with smaller holes. Far ahead, it will likely meet Andromedas. Movement is normal. Monsters do not prowl, they participate. What is inside? The honest, restful answer is, we do not know. The event horizon marks the point where paths all point inward. Beyond it, our current physics cannot tell a complete story. The word singularity is a sign on a closed door, not a picture of what's behind it. Science lives on the edge of what can be tested, and for now the edge is the horizon. Does time stop at the boundary? From far away, light from a falling object slows and fades, so it looks as if time stalls. For the traveler, crossing happens in finite time with no fireworks at the edge. You need not reconcile the views to sleep. The difference is built into how space and time share their duties. Can a black hole die? Very, very slowly. Quantum physics says black holes can radiate a trickle of energy and shrink Hawking radiation. For a supermassive black hole, the timescale is beyond imagination, far longer than the age of the universe so far. On any human or galactic schedule, Sagittarius A times is effectively permanent. Are black holes portals? Wormholes appear in equations, but we have never seen a stable, traversable one in nature. If they exist, they would require conditions we do not know how to build or survive. The sky we measure shows ordinary black holes behaving by ordinary gravity, bent but consistent. Could our black hole aim a dangerous jet at Earth? No. If Sagittarius A times produces any jet today, it is small and faint, more breeze than spear. Jets in active galaxies are narrow and pointed along the poles. We do not sit in such a line. The giant, ancient bubbles above and below the Milky Way likely mark a past episode, impressive and harmless to us. How large is the shadow? Think smaller than the orbit of Mercury. The dark center, outlined by bent light, would fit inside that path. It is vast in human terms and modest on the scale of the solar system. The important part is not the exact size. It is that the shape and scale match what gravity predicts for a black hole with the measured mass. Can life exist near the center? Close in. It is a rough neighborhood, more radiation, more close passes, more tides. Farther out, where the crowd thins, stars with planets should be as common as anywhere. The ingredients for rocky worlds grow richer with time as old stars seed the ring with heavier elements. Can we hear the center? Not sound through air, but we can translate light into notes. Astronomers turn changes in brightness into sonifications, gentle lines that rise during flares and settle back as the ring dims. In the deeper future, when giant black holes merge, space itself will ring with gravitational waves at pitches instruments can detect. What would falling feel like? Long before you reach the danger zone, you would be warmed by light from the hot gas, dazzled by the sky's swirl, and stretched by tides. An astronaut would never file a report from inside. The horizon is a one-way gate. But the prelude, the lensing of background stars, the brightening of the near rim, the odd ballet of time can be watched safely from afar. Do black holes erase information? This is a quiet, active debate. Many physicists think that while matter falls in, information about its arrangement is not lost, but is scrambled and encoded in subtle ways in the outgoing light. Others explore bolder ideas. You do not need the details tonight. Hold the spirit. Even at the edge of certainty, we search for answers that keep the universe consistent. Gather these answers into one soothing scene. See a dark center framed by a soft ring. Around it, a city of stars moves on lawful paths. The ring brightens now and then rests. The black hole neither chases nor snaps. It anchors. The unknown stays politely behind a horizon while the knowable parts, the stars, the gas, the light, offer all the clues we need to feel at home in our galaxy. If questions rise again later, bring them back here, to this balcony above the core. The rules are patient, the pictures are clear. You are far away, safe, listening to the quiet mechanics of a universe that does not hurry. Let the answers close like a book in your lap. The night is long, the center holds. We have looked at the center from many angles, evidence, portraits, futures, and quiet questions. Tonight, gather the pieces into one calm sense of scale, a pocket map you can keep. No heavy numbers, just landmarks you can feel. Begin with distance. The center of the Milky Way is about 26,000 light-years away. A light-year is simply the distance light travels in 1 year, so every photon we catch from the core began its trip when humans were painting caves and telling stories by fire. We see the center as it was, not as it is this second, and that is fine. The galaxy changes slowly, now size. If you traced the black hole's shadow, it would fit inside Mercury's orbit. That picture is enough. The sun, from far away, would look like a bright grain, the ring, like a small coin, the dark middle, a place where light's paths fold inward. Hold that, and let the rest settle on it. Time has its own rhythm. Our sun needs a few 100 million years to complete one lap around the galaxy. Call that one galactic year. During the dinosaurs, we were at a different spot in the lane. During the rise of mammals, farther along. In the time it takes you to fall asleep, the galaxy hardly moves at all. Slowness is a gift. Weight gives the center its authority. Sagittarius A times holds roughly 4 million suns worth of mass, enough to anchor quick nearby stars, too far to tug on us in any personal way. In the giant galaxy M87, the central black hole is thousands of times heavier and easier to photograph because its ring changes more slowly. Different sizes, same rules. Heavy things curve space. Curved space guides light and orbits. From those motions we read weight, the way you judge a book by the way it rests in your hand. Add the neighborhood. Around the core lies a downtown ring where thick clouds turn into clusters of newborn stars. Farther out, the bar of the galaxy gently guides material inward. The spiral arms are traffic waves, not rails. Stars and gas pass through like cars in a slow jam. Outside, the bright disk floats a wide halo of unseen mass we call dark matter. You do not need its details. Imagine a soft, invisible cushion that helps hold the disk together. Now the cycle. Clouds collapse into stars. Stars live, shine, and return part of their substance to space. The next generation forms from that enriched mix. Carbon for breath, oxygen for blood, iron for hemoglobin. These elements were forged in earlier stars and scattered by their endings. The bar brings raw material, the ring builds. Winds and supernovae stir. The core occasionally sighs with a brief flare, and over long seasons the city renews itself without hurry. Bring the senses down to your body. Inhale gently for 4 heartbeats. Exhale for 5. Imagine each inhale as dust sliding along the bar, each exhale as a warm breeze from the inner flow. With every cycle your shoulders drop, and the picture clarifies. A calm hub, a hazy wreath, quick stars drawing ovals, thin threads marking magnetic lines, a patient ring of clouds beyond. If you like anchors, keep 3. First, size. The shadow is smaller than Mercury's path. Second, distance. 26,000 light-years, a message from the age of early stories. Third, pace. Our orbit takes hundreds of millions of years, so tonight is wonderfully still. Those 3 points keep the map steady. Set down common worries. The center is not a drain swallowing the galaxy. It is a deep well that shapes orbits nearby and sits quietly for those of us far away. Flares are not rolling explosions. They are brief brightenings on an already dim stage. The unknown inside the horizon does not erase the known outside it. It simply marks where our measurements end. If thoughts keep moving, give them a job. Picture a single bright knot, circling the inner rim like a lighthouse ember. It grows as it comes toward you, fades as it rounds away, and completes a lap in minutes to tens of minutes. Watch 2 laps, maybe 3, and let the scene return to its hush. The image is a gentle timer, a reminder that even near extremes there are rhythms you can trust. Think too of the people who keep this clock. On mountaintops and deserts they open domes, steady lasers, and listen to radio whispers. Their work is not a sprint. It is a practice, like a musician tuning each evening. Knowing that someone is watching while you rest can be calming. The sky is cared for. Before we leave this chapter, place our home on the map. We live in a quiet spur between larger arms, far from the center, in a neighborhood where stars are well spaced and nights can be clear. The band you see overhead on summer evenings is the disk seen from inside. When you face Sagittarius, you look toward downtown. Turn away and you face the outer districts and the open halo beyond. Gather it all into one sentence you can whisper as you drift. The galaxy is large and patient. Its center is calm and sure, and we are safely circling within its gentle order. If thoughts arrive after that, let them pass like slow clouds across the bar. They move on. The map remains. You have a picture, a pace, and a place. The monster at the center is a maker of curves, not chaos. Its quiet presence holds the city together. Carry that quiet to sleep. Let's follow a single messenger from the center, a photon born near the rim of Sagittarius A times, and ride with it, quietly, all the way to your night. This is not a rush. It is a gentle glide across space and time, a lesson in patience you can feel in your breath. The photon story begins in heat. A small patch of gas in the inner flow grows denser and stirs the magnetic threads that lace the region. Energy snaps free, electrons dance faster. In that brief excitement, the patch brightens, and a photon is released, one of many slipping free like a tiny bead from a glowing loom. It is not alone, but in our imagination we will follow just this one. At first, gravity sets the rules. Space is curved, so the photon's path bends as it skims the rim. For a heartbeat it nearly circles, then finds the narrow route that lets it escape. The direction matters. The side of the ring spinning toward us gives the photon a small boost. The far side leans away and gives less. Many cousins leave on many paths. Ours takes the one that leads, eventually, toward Earth. It leaves a crowded neighborhood. Fast stars carve tight ovals. Threads of radio glow run like strings over velvet. Filaments of warm gas hang in arcs. The photon crosses this busy stage without slowing, keeping to the curve that space allows. Farther out, the glow softens into the bulge, old stars in a thick swarm. Dust lies in lanes like smoke. Invisible colors, dust can blot a view, but our messenger is a radio or infrared photon, a choice that lets it slip through the haze. It threads the lanes, the way a sound threads a quiet room, unhurried and sure. The galaxy's bar drifts beneath, steering slow rivers of material inward. Clouds in the central ring flicker with new births. Winds from young clusters sculpt bubble rims. None of this blocks the photon. It is background music, the city breathing as our messenger passes above the rooftops. The distance to your eyes is vast, yet every step is lawful and easy. Now the wide disk opens. Spiral arms fade into gentle traffic waves. Between the arms, space is calm. The photon crosses the midplane and enters the halo, a thinner realm of old stars and hidden mass. Here the starlight is sparse. Gravity still shapes the road, but the scenery loosens. If you were riding with the photon, you would feel the universe widen into a quiet plain. Along the way, grains of dust and small clouds scatter some travelers and delay others. A few cousins wander and arrive by longer routes. Our messenger keeps its line. On rare occasions, it passes near a compact object, a dead star, a remnant, and the path bends by a hair, the way a breeze nudges a leaf. The bend is tiny, but it is real. Time in your life moves forward. On Earth, people learn to grind mirrors and tune receivers. Mountains gain observatories. Deserts host fields of dishes. Without knowing it, the builders are preparing to catch this very photon, like a harbor lighting a channel for a ship that left long before the lighthouse was raised. At last, the Milky Way's suburbs appear, the region we call home. Our sun is just another star along the lane. Planets swing quietly. The photon does not aim for any of this. It aims for a mirror or a dish, cupped and waiting. It dips through the top of the atmosphere, past layers of moving air that would blur a human eye, and finds a surface ready to listen. The receiver hums. The photon becomes a click in a stream of clicks, one dot in a pattern that, with many twins, adds up to an image or a light curve. In that pattern is the shape of a ring, the hint of a spin, the flicker of a flare. The journey ends as information. Understanding follows, and the picture settles, something you can hold when sleep is near. This story is not a fable. It is a way to feel the scale without strain. The photon traveled for thousands of years across a calm, lawful universe. No walls stopped it. No monster chased it. The center did not roar. It glowed. The galaxy did not rush. It turned. The quiet arriving at a mountaintop is the same quiet that can arrive in your room. If thoughts spin, match your breath to the messenger's pace. Inhale and picture the photon rising from the ring, skimming the curve. Exhale and picture it crossing the bulge. Inhale and see it thread the dust. Exhale and let it pass the arms. Inhale and feel the openness of the halo. Exhale and rest with the photon landing in a waiting dish, one soft click among many. Hold. 2. The human part. A person in a parka checks a cable in the cold. Another stirs a dome at dusk. Someone miles away watches a plot draw a faint hump that signals a flare. Later, across oceans, teams compare notes and align their answers. They are caretakers of a story that began before their grandparents were alive, a story told one photon at a time. Now, tuck the journey into a single sentence you can recall later. A small light left a warm ring, crossed a patient galaxy, and became a gentle dot in a picture that shows the center is calm. That is enough. The map is laid out. You have walked it in your thoughts. When you turn off the light, imagine that ring one more time. The ember moves. The glow breathes. The shadow holds. Somewhere, another photon has just begun the same simple trip, and one night, far ahead, it will arrive to complete the picture again. You are part of that picture now, one quiet observer in a universe that prefers order to noise and rest to hurry. This is the part where the story becomes yours. You have traveled from a quiet suburb of stars to a calm, dark heart and back again, and all along the way the rules were simple and kind. The galaxy moved slowly. The center held. Light took its time and arrived as a whisper. Tonight, let that same rhythm carry you toward rest. Settle your breathing to the Milky Way's pace. Inhale gently, long and easy. Exhale a touch longer. Imagine each inhale as dust drifting along the bar toward downtown. Each exhale as a warm breeze sighing outward from the inner flow. Your shoulders drop, your jaw loosens. The map of the sky settles into place. A soft ring, a steady shadow, stars drawing careful ovals, threads of magnetism like fine strings across velvet. Let the questions you brought here spread out and cool. Will the black hole swallow us? No. Does it rule with noise? No. It anchors, and from that anchor, the city of stars finds its poise. Even the flares are brief, like sparks from a campfire that rise and fade without hurry. The unknown stays politely behind the horizon. The knowable parts, light, orbits, gentle bends, are enough for peace. Picture the center once more, but from far away, the way you might remember a lighthouse after stepping back from the shore. The glow is not loud, it is a presence. The ring brightens on the side that comes toward you, softens on the side that moves away, and then returns to a hush. Somewhere, a single ember circles, steady as a heartbeat. If you follow 2 or 3 laps with your inner eye, you will notice your thoughts slow to the same tempo. Now fold the picture into a small, clear sentence and keep it on the tip of your tongue. The galaxy is patient, the center is calm, and I am safe. Say it once, silently. Say it again with the exhale. With every repetition, your room grows a shade larger, as if the ceiling were a gentle night and the walls were distant hills. You are not falling. You are floating where the map is faithful. Think of the watchers keeping company with the sky while you rest. On a mountain, a dome opens to the stars. A quiet laser paints a reference point. Mirrors flex to sharpen the view. In a desert, a field of dishes turns as one. Atomic clocks keep step across oceans. Hard drives hum with the soft clicks of photons that began their trip before your great-grandparents were born. People check, steady, and listen. The night is tended. Remember the scale that soothed you. The center is 26,000 light-years away. The shadow would fit inside Mercury's path. Our sun takes hundreds of millions of years to go once around the disk. On the timescale of a breath, everything is still. On the timescale of a lifetime, everything is orderly. On the timescale of the galaxy, everything is patient. Let those 3 truths settle like stones in a clear bowl. Now, ease your attention through your body the way a slow wave passes through a field of grass. Forehead, smooth, eyes soft, tongue easy in the mouth, shoulders heavy and warm, hands uncurling, belly light, thighs heavy and steady, ankles and feet warm and far away. Each place you relax is like a dust cloud finding a quieter orbit, moving from a tight swirl into a gentle lane. If any image tries to rush, slow it with a count that belongs to the sky. 8. The inner ring, dense and creative. 7. Bright clusters in their cocoons. 6. The crowded swarm of old stars. 5. Long radio filaments, pale threads across the dark. 4. The quick stars tracing narrow ovals. 3. The soft wreath around a shadow. 2. A last bright ember circling close. 1. A quiet, steady center that asks nothing and holds the map. Keep the list if it comforts you. You can reorder it, skip a step, or stop at any number. The center does not mind. The rules do not mind. Gravity is not a taskmaster. It is the shape of the stage. Your breath is the music. The performance is rest. Let the future drift by like slow weather. Someday, far ahead, two great galaxies will meet and settle into one, and the hearts at their centers will circle and merge. That story is not an alarm. It is a lullaby in a deep register, a reminder that even the largest changes prefer long, graceful arcs. Tonight, there is only the quiet city we have visited and the safe distance from which we watch. If a stray thought returns an errand, a worry, a question, place it gently on the galaxy's bar and watch it drift toward the ring. It will be worked on there, slowly, by time and light and patient rules. You do not need to force an answer. Things in the Milky Way rarely jump, they slide. As your eyelids grow heavier, the ring softens into a glow behind your eyes. The ember fades to a memory. The shadow is not a hole, it is a pause where light does not report back. Take that as permission for your own pause. No messages, no checking. The world will be there when you return. Before sleep takes you, whisper the map one last time. The galaxy is patient. The center is calm. I am safe. If words blur, let them blur. If they vanish, let them vanish. The meaning remains, the way starlight remains even when you turn away. You have reached the end of this journey and the start of your rest. The monster at the center was never a monster. It is a maker of curves and a keeper of order, and from its quiet place, the Milky Way holds its shape. From your quiet place, your night will hold its shape too. Let go, float, breathe, sleep.